All right, everyone, welcome to Improving Talks. We will go ahead and get started. First order of business is to look down at the center bottom of your screen and see that we have a Q&A feature. Jonathan will be taking questions throughout actually designated points in this talk, and we'll also have extended Q&A at the end. So if you have any questions, please get them in. I will get them to Jonathan as he asks for them, and we will get your questions answered. And with that, it is my wonderful pleasure to introduce Jonathan. He has spent more than 9 years building and operating platforms as a DevOps or SRE leader, which is a site reliability engineer. He's a developer first engineer. He knows postponing security only magnifies risk. An independent DevSecOps assessment validated his approach. Services built on his framework were rated as the most secure and the best aligned with DevOps across the client's entire portfolio. In this session, Jonathan will distill the hard-won lessons from selecting and rolling out a DAST tool within that framework, giving you a proven roadmap to shift security left by design. Thank you, Jonathan. Take it away.
Thank you, Bud, for the introduction. I do want to mention right off the top that even though there were those wonderful words at the very beginning, it really was a team effort in execution on this. So I do want to acknowledge that out of the gate first before moving on. So let's talk about how this all came to. Let's talk a little bit about myself, just a little bit more. So who am I? I'm an improver, senior consultant with a focus on DevOps and platform engineering. If you're curious, here's my email and my LinkedIn, and then also my personal blog, in case that's something, if you find what I have here to share here interesting, you can go and follow up with me there, as well as reaching out to wonderful folks here at Improving. So let's start with a story. So imagine you are the Chief Information Security Officer. You're in a meeting discussing the current state of an important service at your company. In front of you is a report from your team, a laundry list of all the problems in the upcoming release. The dev manager, his phone goes off and you looks at the notification and says, "Hey, so you know that new AI feature? It's going to be available to the customer in the next 10 minutes. And what was your gut reaction to that? Did you have a brief moment of dread come because you know that the risks that you've got here in the company are not well managed? Well, our intent through this presentation is to help you move from that feeling of chaos to confidence in the development process. So let's talk a little bit about how we're going to get there. First, we're going to go and cover what DAST is and where it fits within the software creation process. Second, we'll work through to get a pattern of how to identify what are your business goals, who are the stakeholders in order to work with DAST, and what is the criteria that will help make the use of DAST successful. Third, we'll go through a case study about how we successfully rolled out DAST to a client. And then fourth, we'll talk about how to make this new capability stick. So what is DAST? So DAST stands for Dynamic Application Security Testing. This is compared to static application security testing, where for DAST, you're working more with actually running the application, not just looking at the source code and saying, hey, does this look like it will have a vulnerability in it? You're actually running it and then executing attacks against that running code to see, does this actually work? It's kind of like an automated hacker trying to break into your system, and it helps to enable a continuous security validation for your running services while taking the entire stack into account, not just the specific application. So to understand where DAST fits, let's quickly review the typical lifecycle for software. As you can see here, it's usually a continuous loop from planning through development, running the application, taking the feedback from it running, and then bringing that information back into planning, and round and around it goes. This is commonly referred to as the DevOps lifecycle. Now, DAST scans can be run here by the developer while working on a new feature, or during the test phase of a feature, such as during a pull request or as a gate into a production deployment, as well as it can be run against a live deployed system, whether against production itself or a production like environment. But of course, having that additional information is good, but it's not enough. You see, because that just adds onto that laundry list that you have of here's all the additional stuff we have to do. So what is the thing that needs to change in order for this to actually be successful within the organization? Well, to bring it back down to use a first principle, I'm going to turn to Edward Deming, who is the father of modern quality management, who said, you cannot test quality into a product. It must be built in. This also applies to security. The DAST tool on its own just adds to that long list of known vulnerabilities that you're aware of. Helpful for calculating risk, but not good at reducing or mitigating it. You have to find ways to build security in order to actually bring about the benefit that DAST can provide. So again, to bring this back down to brass tacks, your security testing does not make your app safer. It is helpful for seeing what's there, but it doesn't actually make the app safer just having the test present. The team changing how it works, how it invents that software does make a change, does make the app safer. And so therefore, DAST must be a learning tool, not a control. Now, I'm going to reemphasize this. This is the brass tack, okay? DAST must be a learning tool and not a mere control to be checked off. Therefore, you know you are successful when the way that software is planned changes due to the new information that the DAST tool is providing. So I'm curious, what are some of the questions or concerns that you may have at this point?
We do have a couple of questions. What do you mean to use DAST as a control, and why is that a bad idea?
Yeah, so one of the common ways in which we'll often see that I saw DAST sometimes used was that it acted as a check during during a deployment process, where if you didn't pass DAST, if you didn't pass the DAST scan, then it was an immediate nope, you can't go to production. Now, that can be helpful, but it really doesn't change what is the actual security of the application as deployed. Just because you have something stopping a new vulnerability from showing up doesn't necessarily mean that the vulnerability that's in the application itself, that you're not handling vulnerabilities that are already present within the application. So what you need to do is make sure that all a control does is simply say, yep, this thing is, passes this set of tests. It doesn't actually improve the security of the system itself. And so if there's no learning that's coming out of this tool, then it really is just going to be just yet another box I have to check in order to get something out to production, and may eventually lead to people asking the question of, well, why not just remove this? Why do we need to continue to keep this? So that's the main concern around just keeping it as a control. It needs to actually change how you do work, not simply act as a checkbox.
And then another question, this seems similar to Chaos Monkey. Are you familiar with that? What are some of the differences?
Sure. So yes, Chaos Monkey. Now, so Chaos Monkey can function in a similar way. The main difference is that Chaos Monkey was focused on intentionally shutting down existing services in order to see how did your application react. Did it degrade gracefully, or what did it come up with a way of modifying how it was running in order to ensure that the service remained up and it was still a good experience for your users? What DAST does is different because it's actually trying to hack your system. So it's related to, but not quite the same as doing something like Chaos Monkey. Um, because the focus is more on the security aspects, on like what are actual vulnerabilities that are present within the running application, um, as compared to intentionally, say, uh, slowing down network traffic or making a disk go away or killing off one of the containers underlying a critical service, and then seeing how does the application react whenever something like that happens.
That's it for questions at this time.
All right, thank you. Um, Now that we have an idea about how DAST kind of fits into the software development lifecycle and where it makes the most effective impact, let's start building the business case for specifically why you would want DAST in your organization. It's not, we don't want to just say, oh, hey, it's this cool technology, it helps make things more secure. What specifically is the actual business reason that you're going to want to bring it in? And you want to start asking, well, why? Why is this important? Would a business want to focus on this? Generally, when looking at this, the biggest reason, and this is usually the reason you often hear, is that the earlier that you can find something to fix, then the less cost it is to change, um, and the less cost to fix. So the earlier you can find it, this is the whole reason why we're saying, hey, you want to shift left. It's not just, you want the earlier that you can find, oh, hey, there's going to be we might introduce a vulnerability here, or, oh, we might, this is a potential concern that we need to handle. The earlier you can find that and work on ensuring that the design of what you're working on handles or mitigates whatever that problem is, then the lower cost that it is to make sure that that you're actually handling it, whereas if you were to be just waiting until later, then it just ends up costing more. And again, and the other reason why you'd be looking at DAST specifically is because this helps with verifying the entire stack and not just the code for the application. So it means that you're handling things like, oh, all the third-party dependencies, any configuration changes, because more and more often, they're finding that the reason why something is failing from a security perspective is because there was a configuration problem. The application itself could be secure, just that the particular configuration for that was not secure enough. And so being able to test that out before you end up with it being, going into production means that you don't have to deal with the outcome of having that vulnerability exploited in production. And instead it's in order to make sure we weren't exploited in production, we exploited ourselves and we were able to discover this problem. And now we don't have to worry about, and now we've mitigated the problem and we can move forward. So, but the biggest reason is both reducing risk and decreasing costs. Now, once you have that value statement and you've got it clearly for your specific organization, then you're able to go and turn to the next thing, which is to identify your stakeholders. Who's impacted? What are their concerns? And why would they go, okay, sure, that this may be value, this may help to reduce costs and so on, but what I want to do is going to help us make more money, or it's going to reduce costs better, or what have you. So what are the concerns that they have, and what are the things you need to work through in order to make sure that you are doing the right thing for the business? So, for example, take it from the most obvious whenever you're looking at this is thinking from IT security's perspective. Their concern is they want to be able to mitigate known and emerging security problems. And so that's a concern that they have that they want to handle. Looking at it from the app developer's perspective, they're concerned that something like this might slow down development. And obviously, the faster that they can get something out into production, then the quicker it is for them to be able to get the feedback they need in order to say, oh, yes, we've made the right decisions. Now that we understand how the customer is reacting to the changes, we can now pivot towards one direction or another in order to bring even more value to the customer. QA engineers might be concerned about losing focus on building in quality. Now, there could be some argument about that increasing security will increase quality, but there are other quality concerns that a QA engineering would be concerned about that do not involve security, such as performance or does the thing actually do what you're supposed to do? And if you bring in saying, oh, we want to make this security change, and it ends up preventing it from being a good experience for your customers, it's not so good. And then finally, just in general, the entire organization is going to be wanting to deal with trying to mitigate reputational damage from a breach. And so taking all of these concerns is important, because by identifying who is impacted and their concerns, you're then able to drill in a little bit further and say, okay, these concerns all speak to an underlying need that these different groups have in order for them to get their job done. And so then that leads to something that you can start doing for saying, okay, well, if we're going to implement DAST and get the benefits out of it, what is the criteria that help to meet these concerns for what they're doing? So that's what you're doing, is you're collaborating on the criteria with those different stakeholders that you've identified. So you start off with, again, what is the concern that they have? This concern speaks to an underlying need. That need actually speaks to what is the goal that they have. And so you end up with this interesting thing of this concern speaks to both a need, and that need speaks to a goal, and that they need in order to feel like they're getting their job done. The important thing to remember is that this has functional, social, and emotional aspects that we must take into account for what is going to be important in order to get a DAST tool that actually will be beneficial for the company as a whole. By working through all of these needs and goals, you'll identify criteria that the tool needs to meet in order to hire it, because you want to make sure that you're always hiring a product to do a job. So, and from that, you're able to develop testable criteria for what is it that you're needing to do. And at the end of going through all of this, you end up with you want to put together from all the different stakeholders a single combined set of testable criteria from everyone's concerns. And the criteria will be testable when you can score it based upon what are the important about what's important to the organization, and then be able, at the end of scoring each tool based upon that criteria, have a fairly easy go, no-go decision for, yes, this tool will work, no, that tool won't work. And once you've gotten and you've said, okay, this tool meets enough criteria in order for us to be able to, for it to be worth us testing out, now you say, okay, let's go and evaluate, this much smaller set of tools for DAST to be able to say, okay, this is what we're going to work on. So obviously, you've got your testable criteria. The second thing is you also need to make sure you have user representatives. These are people from all the different stakeholders. So you need to make sure you have, again, developers. You need to have your security analysts. You need to have people from QA. All need to be involved you need to have a select champions from each one of those groups to say, hey, I need you to go and help test out this proof of concept to see, how does this score against the criteria that we've all collectively pulled together? So that way then you can, again, come up with that, okay, this one actually fits what we're looking for. And finally, the proof of concept needs to be realistic. You need to either pick an existing product, that where you can actually roll out this tool and use it, or you need to create a model line that imitates the development process that you have at your company for a real product. And when you bring all those together, you will be able to find what is the right tool for the job. And it will also help with creating the playbook for how to pilot that tool on other products. So before we move forward, let's just do a quick check. Does anyone have any questions about the theory that I've covered so far?
Yeah, we have a question out there. How do you make sure that the testable criteria reflect the actual needs of the company?
Yeah. So obviously, since you do have the actual stakeholders who are involved, that helps with getting that first thing. But part of that conversation that needs to be done is to weight the different criteria that you have for what is more critical, what is more important over other criteria. So that way you can say, okay, sure. It may not have the slickest UI, but man, the information that it gives for the developers is fantastic. Information like that. So those you're obviously going to want to go for something that's usable and useful over something that just looks nice, but is just a tech demo. So those are the kinds of things that you're going to want to do is find out what are those specific criteria that you need to weight based upon your company's priorities and then from there it'll make it easier whenever you can say, okay, well, it covered these criteria but it didn't cover those. It makes it a lot easier when having that weight built into the score to how you do scoring to be able to say, okay, this tool meets what we need versus a tool that doesn't.
As you start using DAST on an existing application, how do you handle the backlog?
Yes. Uh, when it comes to that, the and we'll get a little bit into that later, but the big thing is really going over, and this gets a little bit more into how to handle like risk management and vulnerability management, that kind of a thing. But usually it's a matter of following through on the on engaging in what is the actual priority that you have in the backlog for this. This goes along with any existing bugs that are found versus any features that are found or features that are identified where it needs to get prioritized based upon need. Now, if you find something and you need to have it clearly defined as to what you do whenever you say you find a critical vulnerability. Is a critical vulnerability something that I break into the middle of a sprint and say, we found something critical, we're going to have to pause your current feature work and get this thing done? Or is it okay, we may not have, it may not be that important, but whenever you finish up your current sprint, this is going at the top of the backlog for bringing into the next sprint.
All right, that's all the questions at this time.
Okay. For the person who asked that question, I hope I answered your question. And there will be more Q&A at the end in case there's something more specific you want to deal with. All right. So again, since we did cover a lot of theory, we're going to focus a little bit more on the practical. Specifically, we're going to look at how we apply the pattern that I just kind of walked through to a client, and so that way to help you get in a feel about like what is some of the ways that you can apply this practically. So the first one of the questions that was repeated often was like, who gets to see the results of the DAST scan and how much detail is available to them? So like, for example, the devs needed to see the results with suggestions of how to fix the vulnerabilities, and IT security wanted to have a report to help them keep track of the trend of found versus fixed vulnerabilities. And then QA was interested in wanting to know how to reproduce the vulnerability so that way they can include it as part of their regression tests. So this all spoke to the fact that there was a general lack of visibility that they had that they wanted to make sure they could overcome as part of rolling out this DAST tool, because I have seen those times whenever there's oh, we're going to do a security scan on your tool, and you basically just like hand off your code, and then they come back and they're just like, so here's, no, you didn't pass. This isn't secure enough. And you're kind of looking like, but how do I fix it? And they're like, well, these are all of the bugs that we found. It's like, but that doesn't tell me where it found them. Um, and so, uh, going from that lack of visibility, what we ended up having was a local scanning agent that could be run by developers locally, as well, and then it all got reported to a web service, so that way anyone could go up to that service and take a look at the long list of vulnerabilities. What this enabled us to do by getting some of this, we got some additional benefits out of this. One of them was that we actually could get initial reports from repositories before hooking them up into the CI/CD system. That was a great win because it gave us like, okay, is this, are there some things that we want to start tracking now, or is it oh, that looks like there's a lot of noise in this. Let's go ahead and, do some tweaking of the rules to figure out what is, an actual problem versus things that, aren't actually, that are more false positives. And then the other thing that this also gave was it actually gave a way for IT security to test adjustments to the DAST scanner configuration before rolling it out to the rest of the organization. And so you ended up with having this team visible reporting across for all of the different groups that needed to have it. That was extremely helpful, and we were glad to do that, leveraging the StackHawk tool. Then another question that we had was on safe, repeatable testing, because some of these tests are actually attempting SQL injection or remote code execution. These are destructive security tests, and the developers didn't want them messing up their local setup. So IT security wanted as many of the checks run as possible. And then, operations obviously was interested because they wanted to know, like, hey, does this existing application, is it vulnerable to new exploits? Are there things that, possible things that we need to go out there and make changes, say, to our CDN configuration or something like that, that will ensure that this exploit is being mitigated until a fix can actually be rolled out by the application team. So what we ended up doing was creating a test repo that had known flawed code, and then creating a clean room approach where we leveraged GitHub Actions to configure repositories with the appropriate workflow and scan configuration, and created an isolated the application within the CI platform, and then executed the scan using StackHawk's native GitHub Action integration. Because of how we'd set up the system, we were capable of actually running the entire application as we'd expected it to be in production, inside of the CI platform. So that meant that we had a pretty good idea of what was the relative security that we had in place, from whenever looking at it from inside of the firewall. And once we got all that done, we ended up with a repeatable configuration that we could apply to the to all of our different workflows. Again, as I said, it gave us the ability to roll something out across everything, and it gave us a really good idea of what were the problems that we would run into in the real thing. So the next thing, though, that we have to be aware of is that there are going to be some sharp edges that you're going to run into as part of this. One of the sharp edges we ran into that we had to keep going back and forth between security and development was exactly how are we going to allow this DAST scanner to reach our systems. Because we were using something that could be run locally, using like an agent CLI tool. It made it fairly simple, but for thinking through a number of different problems. But even then, there were still some concerns that we had. Like, for example, did we want to expose our dev servers to the outside? This was a problem that we had to go back and forth on, because there were a couple of applications where the best way to test it really was we really didn't have a way to spin up the application inside of the CI pipeline. And so there was this open question. Well, how in the world do we give the scanner at least some ability to run against development, where we get some of the scanning done, until we can get enough of the enough things automated in the CI pipeline to be able to actually do the more destructive tests. Another one had to do with cutting a special, looking at cutting a special environment. Was that something where we needed to like create a new one every time, or did we want to just set up a static one that was kind of production-like that we could run things against, that we would go through and take care of, similar to a staging environment. And then finally, one of the other questions was, how do we give this thing actual access to the application? I gave the example that in the CI pipeline, we were able to stand up the application and get it running with all of the dependencies right there, so that way you could actually test the application and in an end-to-end fashion. But say you're testing something and you say, well, I want to test it what it looks like whenever we actually have a firewall in front of it. How much of the traffic is going through the firewall and actually getting to the application? How much of it is actually being mitigated by the firewall, so that we don't need to worry about a certain class of attacks. Maybe there's a new attack that we were able to discover, and that it discovers that we can actually get it through the firewall, because the firewall hasn't got a configuration set up for it yet to be able to handle that particular kind of attack. So these were all kinds of things that we had to think through whenever trying to figure out, like, how do we make sure that we set this up in as realistic a manner as possible for that application. So because of that, we ended up just finding out what were a few hallmarks of a good DAST tool. The biggest one was making sure to look for things that cover your core jobs to be done. This is the criteria that you were setting based upon the what we decided as an organization was the most important, what we weighted the highest. Making sure that it actually integrates into your pipelines. Having something that was native to GitHub Actions in our situation was key to making sure that this thing was actually successful, because it was able to pull a whole bunch of information out from the run purely because of that, and it made it fairly easy for us to be able to distinguish when a run was being run from CI versus when a developer was running it on their own local laptop. Next one is that this has a break glass option. This one comes into the fact that usually, because of this being used as a control in a lot of areas, sometimes you're in a situation where it's like, I got to get this hot fix out, got to make sure that this thing is deployed within a certain amount of time, and I need to make sure that we're running through getting this out by making sure, so I'm going to turn off a DAST scan to make sure that this build gets through more quickly and out the door. Well, you want to make sure that that is something which gets tracked, logged, and is auditable, and can be documented and referenced later whenever it's hey, we rolled this hotfix out. Yeah, okay, yeah, I got logged and everything else, as well as we had a mitigation later on of having a regularly scheduled scan that we could actually run against what was in production, including the hotfix, after it was deployed, rather than having to wait until it had actually passed the DAST scan to deploy the hotfix. And then finally, make sure that your DAST tool is not just testing and handing you, here are your errors, here's all the OWASP top 10 that you failed to take into account with your design, but also something that gives you solutions, that says, hey, this is the usual pattern that we see. And these are things for you to look through within your code base in order to make sure that you are not vulnerable to this particular vulnerability. And here's how to reproduce it so that way you can very quickly repeat and say, yep, okay, tested it locally, still seeing it locally. And I am able, and because I have the code right there, I can make the fix and show that, yep, I've mitigated that problem and it's not showing up. And that scan is no longer showing up. But the biggest thing to remember is that there will be trade-offs. So even whenever you go through and say, okay, this covers our core jobs to be done, it integrates well with our pipelines, it does enable solutions, there is going to come a point where you can say, well, this, we found these 3 tools and they all fit all of, everything that we need, but there's some variations between the two. You need to make sure that you understand, okay, are we, this one tool might be a little bit better at giving you the solutions that you need, whereas another one is better does a better job of integrating with your pipelines. You need to be able to understand what is the trade-off that you're making for this, and to what degree is this satisfying the criteria that you set up, and what is in a certain sense what is that the level of okay, this fits what we need well enough, and everyone is saying we like this tool, it covers what we need, this is the one, it's the right price point, let's go and use this one. I know we've been mentioning StackHawk a few times here, and I did want to mention a few others that also seem to show these just from an initial pass over, look over, they meet a lot of these hallmarks to also go and look at, because again, just because StackHawk worked for us doesn't necessarily mean that it'll work for you. So you do want to be going and doing your own homework to make sure that you're using a tool that will fit your company's priorities whenever you're picking a DAST tool. Quick question, are there any questions that people may have?
No further questions at this moment.
Awesome. All right. So detour, we're going to talk a little bit about AI. And the main reason for this is because with the changeover, or with the introduction of AI, everything that I've talked up to this point is all based upon information that I had before AI really came in. With AI, there's so many different ways in which it could be applied within this, such as things like, hey, we're going to, increase the number of tests that we can run because we have an AI that can generate tests as much as we need to, and a number of other things. But I wanted to really kind of focus in on a few areas within the DevOps lifecycle based upon what we were doing. So, for example, whenever having that scan result, you can actually have the AI say, hey, I see you ran into this scan problem. Let me go fix that for you. Okay, this is something that, again, taking advantage of the coding agents that we've got, that we've now have, whether it's through GitHub Copilot or Claude Code or any one of these other ones, having them be able to hook into your DAST tool and be able to say, oh, I noticed that you have this thing over here. Let me go fix that. Another example would be, hey, whenever you have a new finding that shows up, you could have an agent sitting there in the background, and this is something that I've actually seen that Copilot has been GitHub Copilot has been working on specifically, but I know you could hook up any number of other AI tools to do something similar, where we'll go and open a pull request on a new finding, where it says, oh, here's a new finding that showed up in the pull request. Let me go ahead and either submit an additional fix to it, or propose a fix to it, or say that there's a new finding that you find out in production. It automatically opens a pull request saying, hey, I saw this error, or this new finding that you found is now, let me go open a pull request for you automatically, rather than having to wait until someone goes and reviews it. So that way you're actually that much further down the development pipeline for resolving a new finding from the DAST scan tool. And then finally, this one is one that I'm kind of interested in seeing happen, is where whenever a finding gets discovered, whether it's new or something like that, having the AI be able to go through your production logs and say, hey, we're starting to see this pattern and it looks like someone is, exploiting us because of this. This means that rather than you finding out, after the fact, you can be more confident that, we found this new finding and we immediately went and scanned through all of our production logs, and the AI comes back and says, nah, you aren't being exploited on this. Well, that gives you a little bit of breathing room on whether or not this is something that needs to be fixed right now, as compared to, oh yeah, that thing, someone is exploiting it right now. We need to immediately let people know, work on mitigating the problem, and actually resolving the the attack, rather than finding out months or later that, oh yeah, we were being attacked at that point. Oops. Now, one of the things I do want to mention, though, is that sometimes what you'll see with some of the more older code bases is that you'll turn on a DAST scan and there will suddenly be this gigantic list of, hey, here's all of these vulnerabilities. And some of them include components within your application that are core to the the service that you're running. And so you're looking and going, well, yeah, we could remove that, but that's going to be, months of work. One of the things that here at Improving that we've been working on has been a tool for doing a full analysis of a code base and then helping to handle migrations. Something that could be like, hey, we have this old Angular JS app and we need to move it up to the latest version of Angular. Or, hey, we have this old JBoss application and we need to move it over to Spring. This is the kind of tool that we could leverage in order to help with resolving a number of those findings, especially ones that have to deal with frameworks that are out of support and for which there are known vulnerabilities that, sure, they may be mitigated, but it'd be nice if we didn't have to have a mitigation layer on top of that, because the vulnerabilities simply aren't. They have been removed by updating to a newer framework. So now that we've back on track, well, before we get back on track, let me ask you, is there any questions that people are interested in regarding our AI detour? All right, I'll assume not. So one of the things that's going to have to be that's really important about this is making sure that when you're exercising this, that you practice the use of this tool. This new capability that you've brought on to be able to do all of this dynamic application scanning is only going to be useful if people are actually using it. Sometimes one of the things that we sometimes would run into whenever we were working on this was you'd introduce the tool, you have the big fanfare, we're introducing this, and then find out 3 months later that they turned it off because, well, it really wasn't giving us the information we needed, or it really didn't fit in with what we were trying to do, and it was just adding noise. Part of, to a certain extent, a lot of that comes down to training, but also comes down to really making sure that you're actually working with the team to make sure that they are practicing and making it part of the normal, part of their normal process. So rather than it being oh, here's just yet another thing that I need to add onto my development process, it becomes well, of course, this is what we do. This is normal. Something that I want to emphasize is that to do this, you really have to focus on doing people first, then focus on helping with training them and bringing them up to speed, then work on adjusting the process, however that needs to happen, and then the technology. So this is the reason why, whenever I was talking through this, why we started with know your why, understand who your stakeholders are, then go through, okay, what are the criteria? What is the process that needs to happen? And then identifying the technology that will actually help you to do that. You always want to start off with people first, then adjust the process, make sure you're working with the people, and then the technology. And And then from that, because by having that focus, you can do the same thing when it comes to the order of making this new capability stick. You have, okay, you've now introduced this new DAST tool. What is it that you need to help people to get to in order to help them understand how to use this tool, understand how it's helpful to them, and then how does it fit within their process? And then helping them, making sure they have the technology that they need in place so that way it becomes just a part of their regular execution. Again, don't forget to practice. Okay, so wrap up. Here are the key takeaways that I want to make sure that we cover. So first is security must be built into a product, not something that's inspected. You can't inspect security into a product. It has to be built in. It has to be something that is part of the planning process. It's part of how your definition of done. It has to be part of how you make sure that you can say, at the end of it, security is part of what we do in order to get this service out to production. Second is the DAST is a learning tool. It's most valuable whenever it's actually helping to inform developers on ways in which the code that they're writing is or is not secure, and helping to also teach them what are ways to make it more secure, so that way, rather than it being a reactive, it failed DAST, let me go make the fix. It should be more of we ran into that. We seem to run into this multiple times. What is the change that we need to make to our process? What is the training that we need to engage in? What is the architecture change that we need to make to the application in order to maybe eliminate this class of vulnerabilities? Third, make sure that you're hiring the tool that best fits your job criteria. Even if you say, hey, we have a new DAST tool, if it doesn't actually help the different stakeholders get their job done more effectively, then it's not going to it's going to end up on the shelf and a very expensive amount of money that is just wasted because it didn't actually fit the criteria of what your organization needed. And finally, make sure you keep people over process over technology, because the organization itself wouldn't exist if it wasn't for the people that made it up. And the processes and the technology are meant to help support them in meeting the goals of the organization as a whole. So that's the end of the talk. Are there any questions?
I'd like to start with a comment.
Yes.
About hire the tool, which I think that is great wording because it means that it is a team member. The tool doesn't work unless you use it, unless it's part of the team.
Yes. Thank you.
Had a question about AI and some of the things that we were talking about with automated pull requests and all that. We still need to keep humans in the loop, even with AI tools. How can we accomplish that?
Yeah. So that's part of the reason why I liked why I wanted to have the AI open the pull request, but the human has to go and review it. The idea of, hey, I'm just going to have some AI go and just fix the problem and I'm not going to worry about it is a bad idea. Because again, it's any automated coding tool is going to be based on what it's seen previously. And even if you're leveraging, a tool that can do a whole bunch of coding for you, you still need to have some level of expertise to be able to understand, does this not only mitigate the problem, but also does this align with the architectural principles that we have in place? Does it make any design decisions that actually makes maintenance harder, and so on? So having it open a pull request with a suggested fix is great, or adding on, or if it's a developer who's created a pull request and then it comes back and says, hey, I have some suggestions. That's exactly what it should be, suggestions. It shouldn't be stepping in and saying, hey, I'm going to just overwrite your entire pull request because it's not doing it the way that I would do it. That's equivalent to having, those developers who are just like, oh, you're doing it all wrong. I'm going to do it my way. We don't want to go have an AI go back to having that kind of a uh, to following that kind of a action. You want them to be helpful and suggestive, but you don't want them to be allow them to come in a certain sense dominate the actual work that's being done. I hope that answers the question.
With DAST as a learning tool, are there common things that you see people needing to learn that people have missed?
So the OWASP top 10 is the top 10 for a reason. It's those are the most common vulnerabilities that people that they keep seeing whenever they go over and do security analyses of different code bases. So if you're looking for like what are the most common things that we tend to do as what we human beings tend to do, go look at those. They do update them regularly to make sure that it's still reflecting the current state of the industry. But like for example, SQL injection is still one of the top one of the top one of those top 10. And so being able to be aware of that and think through when you are retrieving data from a SQL database or something like that, how do you want to make sure that the data is how you validating data that's coming in, and how do you make sure that it's actually doing that you're not trusting data that should not be trusted. How are you handling that? Those are kinds of things which you have to make sure that you are thinking about. But it's so easy to think, oh yeah, everything's just fine, and then it turns out that it isn't. So that's part of the reason why it's good to have that additional check with a DAST tool. But yeah, so definitely recommend going and looking at the OWASP top 10 because to a certain extent it's a great starting point for identifying what are the most common patterns that are found, and then really thinking through how do you break down your application based upon some of those vulnerabilities. Some of them you may not need. Like say you're working on a system where you don't need to worry about a database because what it's doing is it's pulling information from one location and it's putting it somewhere else. If it's something like that, then it becomes more a question of like what is the level of double checking that you need to do as part of that process. But you may not necessarily need to be as worried about SQL injection.
All righty, that's it for the questions. You got about 5 minutes left if you'd like to make any closing remarks.
Sure. So these were the key takeaways. So the thing that I wanted to kind of point you all to is next month's set of talks. So we talked a little bit about AI. Well, next month, we're going to be talking about a whole bunch of different things. So we're going to be going through a 5-part series that does a show and doesn't just tell you. It's not like, oh, AI is going to be amazing, kind of similar to what I was doing where I'm like, hey, here's a bunch of different ideas about how AI can help. No, they're actually going to walk you through, show you how you can leverage AI to go through an entire sequence for building out a feature within a service. It's specifically targeted for CIOs, CTOs, VPs, directors of engineering, people who are just interested in general. So this is what we're going to be focusing on next month. And based upon the little bit of information that I know is going on here and improving, I highly recommend taking a look at this series.